The topic of electronic engineering, Moore's law, is often quoted. The scientist who developed the early transistors. There's a rule that devices double in size around about every 18 months or so. And if you think about that, that means our area is really growing at an exponential rate. So yeah, electronics is everywhere now.
My research is related to organs on chip, trying to make human models of organs so that we can study how drugs are working for drug discovery, drug toxicity.
The research that we do is focused on bio-nanotechnology. So we make little objects and structures the size of nanometers out of DNA. This box will travel around your body, bind to the cancer cell, and only then will it open and release the drug. So it's targeted delivery.
Renewable energy technologies are very significant because of global warming. We need to reduce the carbon emission from our daily life. One of the best options is using renewable energy technology to generate power because these technologies are sustainable.
What we are doing is building this tether capsule that can be deployed inside the stomach. It's a very small capsule. It's meant to be swallowable by the patient. It can be steered and guided by the user, look around through the camera and find abnormalities.
The university is doing quite a bit of work in trying to create devices that could get terahertz radiation working. It's the sort of thing that could be used for astronomy, security, drug screenings, explosive screenings.
And within medical research, they hope to look at them as a replacement of X-rays. So it's quite an exciting field.
My work majorly focuses on consuming less power in data center and in networking in general in communications by using passive devices, being able to do some work that can impact the problem that's happening now with CO2 emissions. That does mean a lot to me.
We use ultrasonics for medical applications, diagnostics, so we're trying to improve the images of, say, hearts and cardiology applications. I'm very keen to make sure that the work that we do actually does have impact on the outside world.
Engineering at Leeds really encompasses a huge multidisciplinary approach.
Mathematics, engineering, physics all together.
And you are taught how to think analytically across different boundaries and interact with different topics. They're hidden within the engineering moniker.
The research component of our work, I think, is vital to make sure that I'm kept up to date with what's actually happening within industry. And
a lot of the research is then fed back into the teaching. It's about having people teaching you who really know and are really keen and interested on their subject.
There are lots of departments of the University of Leeds providing lots of help.
Different majors, different country, different background, and we are working together in teamwork.
There's so much acceptance and inclusion within the university, and it has always been that just me and my work is what proves who I am. That has definitely been a good experience for me here.
There's a lot of exciting things going on, from the very, very big all the way down to the very, very small things the size of 1,000th of a human hair.
The developments that's taking place in our field really are seismic shifts. We can harness all those developments and actually make use of them for some good.
Keep pushing boundaries and see where we can take it, really.